Hey, Dr. Lane, this is my reassessment for Chapter 17. The question I chose has a wire in a loop with a radius of zero point 0.8 meters. It says that it has a current of 6 amps, and the current is going clockwise. And it wants to know that if there was a wire with a radius of zero point 0.2 meters, which would be inside the original wire, with a current going counterclockwise, what would the charge have to be, or what would the current have to be to kind of cancel out the first one to make the total current zero in the middle. So I drew out my diagram, and I know that the magnitude of the magnetic field at the center of the loop is going to be mu times the current times the number of loops over 2 times the radius. And so, because we want to know the relationship between these two, I know that I need the magnitude of the magnetic field from the inner wire, minus the magnitude of the magnetic field from the outer wire to equal 0. So I can set these two equations equal to each other and solve for the current of the inner wire, which I've labeled as wire 2, or just 2, and that gives the current. The current of wire 2 is equal to the current of wire 1 times the number of loops of 1 over the number of loops of 2 times the radius of 2 over the radius of 1. So we're given all of that, so you kind of just have to plug in from there. The current from wire 1 is 6 amps. Each loop, or each wire, only has one loop, so that cancels out. Mu from both sides cancels out, so it's not in the equation. And then we have the diameter of the inner ring over the diameter of the outer ring, and that gives 1.5 amps.